Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to add and subtract fractions. I suppose we've got a couple keywords in that learning objective, but of new to us might be that word fractions, and we're just going to go through what a fraction is and some keywords for that. So a fraction is normally a proportion of a whole number. And the easiest example I can think of is 1/2. So an example, 1/2. And there are a few features we need to be aware of. The number on the top of the fraction is called the numerator. So you may hear me speak about the numerator, or numeration, but numerator. And the number on the bottom is referred to as the denominator, and you'll hear me talk about the denominator as well. And I suppose the next bit, today's video is going to focus on the adding and subtracting. So adding and subtracting, and I just want to note these rules will be different to the rules you need to know for multiplying and dividing. So keep those in mind as we're going out stuff. So we'll go through a couple scenarios. So the first one, let's say we've got 2/7 plus 1/7. The way we do these, when the denominator is the same, so same denominator, you can just count up how many sevenths we have. We've got 2 up the top, and then another 1, and the bottom number doesn't change because they're still sevenths. And when you finish that up, you get 3/7. And that makes sense because you've got one of them over there, another over there, and another over there. It's not always going to be that simple where the numerator is the same. Sometimes we need to do a bit of maths trickery to manipulate or make sure we have the same numerator. And that's where the complicated parts are going to come into it. So let's say we've got 1/3 plus 1/6. We need to figure out what that equals to. The key thing I want to emphasize is those denominators, they are different. So we've got different denominators. But I'm going to call these ones easy because we can see that 3 and 6 have a pretty clear relationship. So what we're going to do is we're actually just going to manipulate or change the 3/6, also the 1/3, to make sure that that has a denominator as well. So what we're going to do, this one here, we're just going to simply times it by 2. And what that does is that 3 is going to be multiplied to a 6. So that's going to become 2/6 plus 1/6. So hopefully you can see that. So that 2 is the 2 times 1, and that 6 is 3 times 2. And now that the denominator is the same, that looks a lot like the question from above. We're just going to add together the top. So 2 plus 1/6 equals 3/6. And we can simplify that fraction to get us 1/2. So that's pretty easy, those ones. So you'll see a lot of other ones. We'll do one more example of those, and then we're going to get into some harder ones for today. So number 3, let's say we've got 1/4 plus 3/12. What you could do is you could simplify this fraction. Those both become 1/4 as well. So it'll be 1/4 plus 1/4. Or you could increase the 1/4 to have a denominator of 12. And we're going to do that again for this one here. So that portion there, we're just going to times that by 3. And that will result in a denominator of 12. It's going to be 3/12. So that 3 being 1 times 3, and that 4 also being 3 or times 3. We're then going to add the other 3/12, and that there combined will be 3 plus 3/12, which is going to be 6/12, and you can simplify that to get 1/2. So that's another example, those last two being fairly similar. Now what I'm going to do is I'm going to pause the video and we're going to get into some harder scenarios where we need to know something called the cross-multiplying method. Okay, question number 4. Let's have a look at 2 over 3 plus 1 over 5. So the thing I want to point out again, the denominators are different. So we've got different denominators. And the big thing I want to emphasize is those denominators aren't easy. I can't just multiply the 3 to get to a 5, or I can't just divide the 5 by 2 to get to that 3. So they're a bit different. And when this happens, we need to do something called, we need to cross multiply. And I'll show us what I mean by that. So we need both of these fractions to have the same denominator. So we're just going to multiply it by the opposite denominator. So this fraction here, 2/3, we're going to times that by 5, which is the opposite. That's going to become 10 over 15. I'm then going to do the same for the second portion, 1 over 5. I'm going to times that by 3, which is the opposite denominator. That's going to be plus 3 over 15. We've now got the same denominators. We can carry on the same process we learned before. So that's going to be 13 over 15. And I don't think I can simplify that fraction anymore. So there's our final answer. So let's have a go at another one. So question 5. Let's say we got 1 over 2. We'll keep them simple. Plus 1 over 7. So key thing again, different denominators, 2 and 7. And I can't just divide 1 by 2 times 1 by 4 to get the other. So we're going to need to cross multiply. Again, so the first part we have to times by 7, which is the denominator on this side. And the second part we're going to have to times by 2, which is the denominator on that side. So let's get into that. So that's going to be 7 over 14 plus 2 over 14. And when we add those together, that's going to be 9 over 14. To focus on addition, I just want to emphasize the same rules apply for subtraction. So we'll get into one of those. So let's say we've got 4 over 7 minus 1 over 7. These have the same denominators. So we can just simply do 4 minus 1 over 7, which gets us to 3 over 7. Example number 7, we're going to have a look at another subtraction result or scenario. So let's have a go at 2 over 3 minus 1 over 6. So if you have a look at the denominators, they are different, but we can easily multiply the second one by 2 to make sure we get to that 6. So that there will be 4 over 6 minus 1 over 6, which is going to be equal to 3 over 6. And if you simplify that, 1 over 2. So same things apply to that. And then number 8, you can also use the cross-multiplying method for subtraction as well. So let's do 2 over 9 minus 2 over 5. So to get the same denominator, this fraction needs to be multiplied by 5, which is the opposite denominator. And this fraction needs to be multiplied by 9, which is the opposite denominator. That's going to become 10 over 45 minus 18 over 45. When we do that subtraction, that's going to be negative 8 over 45. And just a reminder, whilst we have a negative fraction or a negative number on the top, don't be afraid. You can have negative fractions. There's nothing wrong with our working or our answers. We've gone through addition, we've gone through subtraction, we've mentioned same denominator, different denominator. We're going to go through one final, our hardest scenario. Scenario number 9, I've changed the yellow pens. Let's say we've got 1 over 2 plus 2 over 3, and then we're going to subtract 1 over 5. So we've got our 3 parts to that. And the trick, or the approach I like to use, I'm just going to focus on the first pair, and then I'll worry about that last bit afterwards. Let's focus on the 1/2 plus 2/3. So what we're going to do here, we're just going to times that by 3 and times that by 2. So we're doing that cross multiplying. So that there is going to become 3 over 6 plus 4 over 6. And this minus 1/2, we haven't done anything with that. It's going to be minus 1/2. And that's going to result in 7 over 6 plus 1 over 5. Now that we're at this step, we can just repeat that same process that we did. So 6 and 5, the denominators are different. I can't add, or I can't multiply easy to change one to the other, so I have to cross multiply again. So that first fraction, I'm going to times by 5, and that second fraction, I'm going to times by 6. So 7 times 5 is 35, 6 times 5 is 30. I'm then going to add 1 times 6, which is the 6, and then the 5 times the 6, which is 30. And when we add that together, that's going to get us to 41 over 30. And that there would be the final answer for that simplified fraction. So hopefully you found the video on adding and subtracting fractions useful. We went through 3 different methods. All of them have relevant context and scenarios that they can be applied to. Now let's get into heaps and heaps of practice.